Okay, so now we'll be discussing about the high energy compounds. So this is a bacterial cell. In this bacterial cell, you can observe that in the picture, there's a complex polysaccharide. It can be starch or cellulose, which is converted to glucose, and the glucose enters the cell. You can see in the center of the cell at the top there. Okay, starch is broken down to glucose. That glucose 6-carbon compound enters the cell, undergoes glycolysis to give pyruvic acid. In the process, they give ATP. So that is why substrate level phosphorylation ATP can be generated. So we are telling how ATP can be generated and how ATP is a high energy compound together. So we should answer like that. So ATP is formed. Remember that during the glycolysis and Krebs cycle, there's also formation of NADH2 and FADH2. Keep this in mind. Okay. So coming to the first one. What is the first one here? ATP formation we are discussing by substrate level phosphorylation and oxidative phosphorylation. You can see that NADH2 and FADH2 enters electron transport chain, and then by oxidative phosphorylation, you can see the diagram of ATP synthesis and a small one where ATP is forming. Okay, thus ATP is formed. First, you tell this point when you're talking about ATP. So ATP is generated. The first high energy compound is ATP. ATP is having 3 phosphates. The next box diagram shows that. Adenosine triphosphate with squiggle bonds. When squiggle bonds will break, there's a spontaneous hydrolysis of ATP and giving rise to energy. Delta G minus. That is energy released. So I told you, whenever ATP breaks down to ADP plus inorganic phosphate, one squiggle bond is broken and that is giving energy. That is called minus delta G, 33 kilojoules of energy per molecule. When the second phosphate is removed, again squiggle bond will break. The energy release is, of course, 12 kilojoules, but it's all called as exergonic. Thus, we get energy formed from ATP. First, you should explain all this. Then, thus, energy which is released is useful for doing the work. So, connectivity of concept. There we'll say work is not 100%, some amount of energy is lost as heat, all that you will explain it there. But here you are only telling which are the different high energy compounds. Okay, the second high energy compound is called inorganic polyphosphate. So all of you concentrate properly, understand whenever ATP is broken down to ADP plus inorganic phosphate, okay, I said energy is released. You all know that now. This inorganic phosphate which is free now can again connect to another inorganic phosphate and slowly become a chain of inorganic phosphates. This is called as polyphosphates. Remember, these polyphosphates will have number of squiggle bonds. Those squiggle bonds all are giving energy. That is why inorganic polyphosphate is also considered to be as one of the high energy compounds, because so many squiggle bonds will be there. They'll all break down and give energy. That is called inorganic phosphate as one of the concepts. Polyphosphate as one of the concepts of high energy compounds. Thirdly, I'm talking about AMP, adenosine monophosphate. Let us connect how all AMP is relatedly present. Okay, why have we written about ribose 5-phosphate here is ribose 5-phosphate helps in generating by multiple reactions. It may generate ATP, may generate GTP, and it might even generate AMP. AMP means adenosine monophosphate. GTP means guanosine triphosphate. ATP, you all know, adenosine triphosphate once again. So this ATP, I'll come back to that ATP afterwards. ATP connectivity, you all try to understand that. Okay, ATP is coming by glycolysis also. ATP can come from ribose 5-phosphate also during the breakdown and like that. So talking about AMP, third one, you can see the Roman letter 3 there, adenosine monophosphate. In presence of protein kinases, it helps in fatty acid catabolism. Okay, fatty acid catabolism ends up in giving ATP. Okay, that ATP means fatty acid are broken down. That time ATP is released. That ATP again undergoes same mechanism of spontaneous hydrolysis. You're only trying to tell which all ways energy compounds can be formed. First one was ATP. Okay, second one was inorganic polyphosphate. Third one is adenosine monophosphate, which is generated from ribose 5-phosphate. Okay, so fatty acids are another source of high energy compound. So that's why you are trying to show that also there. Fatty acid catabolism gives ATP. And also we can show that. Okay, thus ATP is formed by various ways. Coming to the fourth one is talking about phosphoenol pyruvate as a high energy compound. From where you get phosphoenol pyruvate? Through glycolysis from glucose, right? That is why I've written down that glucose molecule enters the cell and that glucose can be converted into phosphoenol pyruvate through glycolysis, EMP pathway, and that also acts as a high energy compound. Why and how? See the structure there. Phosphoenol pyruvate structure is written here. COOH, COP, CH2. Okay, the COP means when you take carbon and oxygen, there's an ester linkage present there. The ester linkage also gives energy, free energy. That is why we'll say that ATP is forming there. Like that we'll just show that. So there's a formation of energy when the phosphoenol pyruvate converts into enol ether. Directly, phosphoenol pyruvate will not form pyruvate. Okay, directly it will not form. In between, there's a component called as enol ether formation. So you can see the structure there. COOH, COH, CH2. That means what happened there? It's intermediate compound. It's imbalanced to convert to pyruvic acid immediately. But understand that between these two steps, PEP and enol ether, energy is released. Why? Because there's an ester linkage between carbon and oxygen near the phosphate. Okay, that's how we'll call phosphoenol pyruvate as one of the high energy compounds. The same to continue, pyruvic acid can be formed by glycolysis. That time it can convert to acetyl CoA. Talking about the fifth one as one of the topics is acetyl CoA as a high energy compound. Acetyl CoA is formed from two methods. One is by glycolysis to give pyruvic acid and you get acetyl CoA. And other ways also we can get acetyl CoA by beta oxidation of fatty acids. I'm not shown beta oxidation of fatty acids. It's just to tell you, I'm telling that. You can write down there if you want. Beta oxidation of fatty acids also can contribute for acetyl CoA. Okay. Now, how would we call acetyl CoA as a high energy compound? See the structure: COA, S, COR. Between the sulfur and the carbon, we have the thioester bond. Thioester bond is also a high energy compound. Is high energy bond. When it breaks, it can give energy. Okay, so we can say that the fifth one is acetyl CoA as a high energy compound as a heading. Then you can say how acetyl CoA can be formed, you can tell, and then you can say that the structure wise when you see has got sulfur and there's a linkage of thioester bond between S and C. Therefore, when the ester bond breaks, it can give energy. This is the fifth one. Coming to the sixth one, consider it properly. In the diagram, you can see after ribose 5-phosphate, I've shown ATP there. ATP can be converted to cyclic AMP through pyrophosphates. So please understand, children, pyrophosphates are again a source of ATP. From where we get pyrophosphate? From ATP. How? When two phosphates are linked, okay, only the adenosine is left behind with the phosphate, adenosine monophosphate. Okay, that time you get pyrophosphate formed. Means ATP is it gives AMP plus pyrophosphate. So pyrophosphates will be formed in the cell. Those pyrophosphates also contribute itself as a high energy compound because they'll convert to cyclic AMP when pyrophosphates are more in the cell. Whenever cell has got more of pyrophosphates, they will become cyclic AMP. Just like I told you, whenever phosphates are inorganic phosphate is single phosphates, they are more in the cell, they convert to inorganic polyphosphate. Like that, here we are discussing about pyrophosphate. Pyrophosphate help in formation of cyclic AMP. Cyclic AMP is said to be a reserve energy compound in the cell. Cyclic AMP, when ATP is less, they'll support the cell. Cyclic AMP converts to again adenosine through ATP, it becomes adenosine monophosphate. Thus, we get the another high energy compound from cyclic AMP, that is ATP or AMP. So when they break down, again squiggly bond will break and gives energy. All of you understood till here? Was I fast? You followed? Hello? Can you hear me?
Yes, sir, we understood.
You understood now? So there are different types of high energy compounds. You're just telling them, listing them by naming different types and how they will come and where they will be formed, like that. Anything you didn't follow, please tell me. I can repeat it here now at this time. Seventh one is NADH2 and FADH2, which will go to ETC and help in formation of ATP by oxidative phosphorylation. So 7 different steps you have to tell children. Can you see the slides?
Yes, sir.
But one second, my screen is not visible. One second. Okay. So till here, any doubts are there, you can ask me, ma. Okay, the remaining slides are telling about the same information which I have shared in the form of a diagram. So you see here, one second. Lippmann, Fritz Albert Lippmann invented this notation of squiggle bond. Remember that? You can just read through some notes which are given here. Pyrophosphates, enol phosphates, acyl phosphates. My screen is not displaying. I don't know why. Few minutes, just give me some time, children. My display is getting off. So here you can see enol phosphates. I told you COH, CO. See, there's a thiazide bond here, which will help in giving energy. Acyl phosphates. You see, wherever there's phosphates, they can be considered to be high energy compounds. See here, thiol phosphate. Wherever S is there, Acetyl CoA, for example, thiol phosphates. Phosphates. This is again talking about GTP and GDP. See, pyrophosphates, acyl phosphates, enol phosphates. I mean to say 1,3-diphosphoglyceric acid can also be considered here. Carbamyl phosphate can also be considered here. Wherever phosphate links with some components, we can call them as high energy compounds. They're called acyl phosphates whenever they link like this. Enol phosphates means phosphoryl pyruvate, as an example I've told you. So they're called enol phosphates. Wherever the phosphate links with the carbon and oxygen, no? So there's a squiggle bond formation. They can help in ATP, energy generation. Thiol esters, you can see acetyl CoA as an example. Gonadophosphates means wherever you have phosphocreatine, phosphoarginine. Arginine is an amino acid. So when there's a link of this also, when the bond breaks between the two, they can generate energy. Okay, whatever I've told you, that much you read, it's like I think will be enough. And here you see phosphoryl pyruvate can give 14.8 kilocalories per molecule. My display is some. You can see the display now.
Yes, sir.
Okay. Carbamyl phosphate is also one of the high energy compound which can give. What is the meaning of minus here? Energy, free energy is released. Free energy will be released. 12.3. Cyclic AMP can give 12 kilocalories. 1,3-diphosphoglyceric acid can give 11.8. Phosphocreatine can give 10.3. Acetyl phosphate can give 10.3. Pyrophosphates can generate 8 kilocalories per molecule of energy. Acetyl CoA can give 7.7. Like that, you can understand that every component which is having some specific bonds can help in ATP synthesis. Means not ATP synthesis, sorry, can give free energy. Not only ATP breakdown will give free energy, these components also, when they break down, they give free energy. Okay, that's how you can just list them out. But explain whatever I had given you, explain them. But here you can list them out just as a conclusion that these also can at least pick up 3-4 examples and mention that they also can give free energy. So that's what you should learn in bioenergetics. Okay, 2 things you should remember: concept of bioenergetics and high energy compounds. Any doubts in this, children? You followed this? Send you the notes also. I think notes is given, but remaining some more points I will send it to you on the Google. This diagram is important. It's useful for you. Practice this diagram. I'll send you this one. I think I'll send a PDF of this slides to Harshit and he will forward it to you. Okay. Any doubts in this? You can. The way I have explained it, you go with the same pattern. Consider these as the main high energy components. ATP, NADH2 FADH2, inorganic polyphosphate, acetyl CoA, phosphoryl pyruvate, AMP, cyclic AMP, GTP, pyrophosphate. These all are considered to be high energy compounds. Any doubt in this, children? If you have any doubt, you can ask me. We have some time. Next class, we can go with biomolecules. Arshit, I've taken attendance. Yes. Any questions?
Yes, sir.
Follow? You understood? How to write this answer?
Yes, sir.
You should pick up some points. Only 2 types of questions will be asked. Write a note on concept of bioenergetics, or just say ATP as a high energy compound. You should know how to write the answer. You can connect ATP with cyclic AMP, pyrophosphate, many things you can write together. But please answer smartly. Wherever you have ATP as a high energy compound means don't tell that ATP first bond, second bond will break, then energy it is only that much you don't tell. ATP connects with inorganic phosphate as a complex. ATP also connects with pyrophosphate. Like that you write ATP as a high energy compound. When you ask, ATP itself is connected with so many things. Like that you should write your answer. Are you able to understand?
Yes,
I
sir.
told you. If they give ATP itself as a high energy compound, that time you should write about ATP structure. This one, basically, not even this, at least this diagram, basic diagram. Tell about ATP hydrolysis, tell about the squiggle bonds and all those things. Then in this diagram, if once again, in this diagram, you can connect ATP relatedly in many places. You can connect ATP with inorganic phosphate, polyphosphate, can connect it to even cyclic AMP and also connected to pyrophosphates. Like your answer should be there. The general question is asked high energy compounds, then everything you should write, whatever I listed out now. ATP, inorganic polyphosphate, then acetyl CoA, then you should talk about phosphoryl pyruvate, then you should talk about individual ones. AMP, GTP. One is in triphosphate, also will have phosphates with squiggle bonds. When they break, they also give energy. So GTP and ATP goes almost together. Only thing is ATP is adenosine triphosphate, which can convert to reserve bodies like cyclic AMP, but GTP is not majorly contributing for that. That's all. That's why it's called second high energy compound, not a main high energy compounds. Okay, now children, all of you followed this diagram. You should practice. It become easy for you to represent the answer. That's the reason. So they'll understand, okay, everything is there in this diagram. The student has understood how to write the answer. Then you can write points, 10 points will do. Okay. Yes.
Yes, sir.
Okay. So next class we'll meet for biomolecules. Somebody has sent some chat. Just check who it is. Yes, sir, attendance is taken. No, Harshit cannot speak, so it's messaged. Okay. So I think we'll end up the class now. If you have any doubts, you please ask. Otherwise, all of you practice properly all the flow charts, practice the diagrams wherever necessary in oxidation of inorganic compounds. Practice the diagram. No need to by heart anything. You can write your own way of answer. And coming to the fermentation pathways, learn the flow charts. I've told you how to go on with them. And I'll send you the notes of the fermentation I've sent you, but in that lactic acid is not there so clearly. I'll send you once again some more fermentation notes. Refer whichever is comfortable for you. Please go through that, read it properly. Then I'll give you some question bank also. Follow it up. For biomolecules, I'll keep some things mainly, and then I'll discuss those points. Go ahead with that, and then we'll go with the one class of revision for the questions. Okay, I will keep that revision class maybe after 20th is fine. 22nd, like after, means your exams will start off on 24th. No, when you don't have exam, which day? Before microbiology, you'll have how many days?
3 days, sir.
Okay, which is the last exam before microbiology? Which day?
English.
English.
Huh?
General
Sir, English is 28, sir.
Okay, just check and tell me. One of you can tell me which day is the last exam. That day evening or something, I will schedule the meeting. Maybe, okay. That day or next day I'll schedule. We'll have 3 days time, no? For
Yes, sir.
when shall I have a revision class, question revisions?
28th evening, sir.
28th or 29th I will keep based on the availability, so that we can at least revise, and I'll send you the question bank. You start reading. Maybe I'll just interact with you for lesser time just to make you understand if some doubts are there. Okay. Okay, no?
Okay, sir.
All of you have the question
Sure, sir.
papers with you? Old question papers?
Yes, sir.
Yes, sir.
From which year you have? 13. From which year you have the question papers? 3 years? 5 years?
5 years.
5 years you have. Okay, okay. Go through them. I'll send you question bank, and I'll send you some pattern of writing. You should not miss it out. 2 marks, how to write. I'll send you a few questions. Go through them. You may get some idea for modifying for everything else. Okay. Fine then. Shall I end the class now?
Yes, sir.
Okay. Okay.
Sure, sir.
Okay. Bye then. Take care. We'll meet in the next class for biomolecules.
Thank you, sir.
Thank you, sir.
Okay. Thank you, sir. Okay.